Here we show a student priming a pipette. Priming is a cleaning process in which you clean the pipette with the same chemical liquid that the pipette will come in contact with during the experiment. Here you can see that first you draw the liquid using the bulb and then drain it. Repeat this 3 times in order to properly prime your pipette. Here we have a drawing of a pipette, which is a glass tube used to measure volumes of various liquids. In order to read a volume within a pipette, you must look at the bottom of the meniscus. As you can see, here we have a curved edge of the liquid that is called the meniscus. The reason that water does not lie flat in a pipette has to do with the polarity of water and the glass molecules themselves, which cause the water molecules or liquid molecules to attract to the edges, thus making this bubble shape, which we call the meniscus. So, in order to read the pipette, you look at the bottom of the meniscus. Hold the pipette eye level, take it across to the calibration mark that it's closest to, and there you record your answer. Here you can see Mallory drawing up a solution with a pipette using a bulb. Then she places her finger over the end of the pipette to stop the flow, and she reads the initial volume, which she determines to be 4.80 milliliters. Next, she transfers from the pipette to the reaction vessel, which in this case is a beaker, stopping the flow once again to get the final volume. She records her answer as 3.05 milliliters. Here we have a second example of a student drawing a solution and finding the volume. Here, Saif will go through the same steps as Mallory did. He finds his initial volume to be 3.2 milliliters. He then empties some of the solution into the reaction vessel, finding his final volume to be 1.19 milliliters. We have a third student who will do the same steps that the other two did before her. Here, Parker is seen drawing a solution and determining the initial volume, which she records as 3.46 milliliters. Next, she too will empty some of the solution into the beaker in order to determine a final volume, which she records as 2.17 milliliters. And just to make sure you didn't catch it the first 3 times, here's a fourth student to show it to you again. Here, Key draws a solution, determines the initial volume to be 1.54 milliliters. Then she too drains some of the solution and finds the final volume to be 0.82 milliliters. In order to find the volume delivered, you must subtract the final volume from the initial volume. Key's volume delivered was 0.72 milliliters. This is what your data table should look like once you have recorded all of your volumes that you found.